Good morning. Two bulbs connected in series. Let us see two bulbs connected in series to voltage. Let us take it 100 watt, 80 watt, connected to a 220 volt supply. Now, what we get is here, what is the resistance of the bulb? So we know power is equal to V squared by R. That is, power is inversely proportional to the resistance. That means R80 is more than R100. Since they are connected in series, same current is flowing. So R80 is more than R100. So when we connect this in series, what happens is 80 watt loss more than 100 watt. 100 watt. Because resistance of 80 watt is more, so voltage in the and what we get is power. Power is I squared R. That will be more in this case. So this is lot more. Now let us see. Just consider 100 watt 220 volt bulb, 80 watt 220 volt bulb. Now we see what is the current flowing. Power is 100 watt. Power is 100 watt. In this case, voltage is 220 volt. Now, you know, V squared by R is power. So we can tell the resistance. Let us see this 100 watt 220 volt, 80 watt 220 volt. Now let us see the resistance. You know, V squared by R is P. So V squared by P is R. V squared by P is equal to R. That means V squared by P is equal to R. Here it is 220 squared by 100. This R 100 and 220 squared by 80 is R80. R80. So these are the relations. Now 220 squared by 100 is equal to 220 to 220 by 100. That is 22 into 20, 22 squared. So R100 is equal to 22 squared. 22 into 22. That is 484 comes. As you can see there, 484 ohms. There is R100. Now R80 is equal to 220 into 220 by 80. Here it is 4, here it is 11, here it is 2, Here twist it on. 100 now. So that is 55. 55.11. Yes, 50.11 is equal to 55. 55. 605. 605 ohms. So now we see the resistance 8 is more than resistance 100. Now power dissipated. In series connection, power dissipated across R100 is or we can find out the current also. If we need, we can find out the current also. How we will find out the current? That is 220 volt. Current is equal to 220 volt divided by 605 plus 484. This is a current. That is 220 by 109. So you can get 220 by 109. So this is the current. This is the current in the circuit. Now current into resistance, you can find out the voltage across each bulb. So you can find out the voltage across each bulb based on this. Okay. Now I squared R, we can find the power dissipated. I squared R. We can see the current is with one division, you get 0.2026 ampere. And now power across the 100 watt bulb is equal to, that means in series the power will change. This power will be 0.2020 squared into this P100 is equal to, I squared R, R100 is equal to 484. 484. Let us calculate. You can see the value is 0.2020 squared into 78484 is 19.74 watt. This is the power dissipated across 100 watt in series combination. And now power dissipated across 80 watt, P80. Same way 0.2020 squared into R80, which is 605. And equal to see this across power across 80 is 2020 into 605 into 24.68 watt. You can see here. Now this way it will change in series connection, and 80 will glow more than 100. Right. Okay. Now that means resistance of 80 is more than resistance of 100 in series connection. Okay. Now see this across power across 80 is 2020 into 605 into 24.68 watt. You can see here. Now this way it will change in series connection, and 80 will glow more than 100. Right. Okay. Now that means resistance of 80 is more than resistance of 100 in series connection. Okay. Now Now let us go to parallel connection. 100 watt bulb is connected to 80 watt bulb across 220 volt. This parallel connection is used in our house circuits. In house circuits, parallel connection is used. So we know across 100 watt there will be 100 watt, across 80 watt there will be 80 watt. So P100 is equal to 100 and P80 is equal to 80 watts. No change. Both will be same. Now we can see the current in each one depending upon this 220 volt across 80. So we know power is equal to V squared by R. You can find out the resistance. That is 220 squared by resistance across 100 by 100. Resistance will remain same. Resistance will remain same. Not change. 484. Since the voltage is same, resistance will not change. Okay, now we say R80 is same as 605 ohm. Okay. So what means is this resistance is more, the current will be less in 80 watt. And current will be more in 100 watt. So the current flowing, this circuit you can find out 220 by I100 is equal to 220 by 100. Sorry, 220 by resistance 484. 220 by 484 equal to, you can see here, I100 220 by 484, so value is 0.4454 ampere. 220 by 6.6364. P80 is I squared R 0.364 squared into 605 equal to 80 watt. And P100 is 0.44, the 484 is equal to 100 watt. So 100 watt will glow more than 80 watt. See, in parallel connection, 100 watt will glow more than 80 watt. In series connection, 80 watt will glow more than 100 watt. Now let us see 200 watt bulbs in series. When 200 watt bulb is connected in series, total power equal to V squared by R equivalent. And V squared we know 220 volt, and our 220 volt. 220 volt. So 220 divided by R equivalent. We know that R100 volt, R100 is equal to we know R100 is equal to 484. So 2484 in series, 2 into 484. But this you are getting here. $220 into 220 divided by, so that is you can do it as, to get this 220 into 220 by 2 into 484, that is equal to 50 watt. So equivalent resistance, so total power of the circuit becomes 50 watt. Then 200 watt is connected in series. Okay. Now let us take 200 watt bulb. The cost 220, 100, 100. Now we know R100 is equal to 484 and equivalent resistance equal to parallel connection. This is 484 by 2. And this 242 ohms. So what is the power? The power is V squared by 242, which is 220 squared by 242, which is equal to let us see another question. Two, 3 connected. To a cell and its resistance is same. Now the condition is their section. This is one section, this is another section B. Then condition is this: all bulbs glow in section A. All bulbs glow section A. And two from side A glowing. Side A glows. 2 from side A glows. And 1 from side B glows. 1 from side B glows. The question is like this. So what is here? See, all bulbs glow means current will be passing through all the resistance. All bulbs glow means current will be passing through all the resistance. Now if a current I is coming from here, it will be divided into I by 3. Here also I by 3. Let us write another drawing here so that will be more clear. So first, whole bulbs glow. Whole bulbs glow. Whole bulbs glow. Here you can see here the current I is going. Current I is going and it is quickened by 3, I by 3. Since it's a parallel circuit which is having the resistance of R. Here also there will be I by 3, I by 3, I by 3. And this resistance R. Okay, now this resistance and parallel. So you get the equivalent of section A. Section A equivalent resistance is equal to R by 3. Section B also, since all bulbs are glowing, current is passing. Section B also the equivalent resistance is R by 3. That is total R equivalent is equal to 2R by 3. 2R by 3. Now what is the power? The cell voltage is C. Now power is equal to E squared by R. That is equal to E squared by 3 E squared by 2R. Okay, this is the power. Now next is section B says, second step says second is 2 from A and 2 from A and 1 from B. So 2 from A means other one is no current is flowing through that circuit. Only 2 resistance will come into action. 2 section A and 1 from section B. Circuit will be like this. So this is R by 2, R. So here equivalent, R equivalent is equal to R by 2 plus R, which is 3 by 2R. So the power is equal to E squared by R, which is equal to E squared by R. E squared by 2 by 3 R. 2 by 3 R. Now ratio. You have to find out the ratio. Let us find the ratio of this P1 by P2. P1 by P2 is equal to P1. What is P1 is 3 E squared by 2R into P2 is 3R divided by, so PR divided by 2 E squared. Get cancel R. So that is ratio is 9:4. 9:4 is the ratio. Let us see the first section. You see the section A. What happened is, this resistance, here also resistance, here also resistance, is connected to a cell. But note that this is a common pole. So you can say it is series like this, parallel, and then it is series with the resistance here. So resistance here. So resistance here. Like this. So each is R, 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 R. Now the current is divided. I will divide into I by 3, I by 3, I by 3. Again comes I here. Again comes I here. Again divides into I by 3. Again this will be I by 3, I by 3, I by 3. Here also I by 3, I by 3, I by 3. I hope you understood.